Nick from the Peoria Riverfront Museum, and we got the infrared camera out. We're going to look at this invisible color called infrared light again, which is right next to red, so we can see the visible rainbow of light, but there's invisible colors next to red called infrared, and then microwave, which you use to cook your food, and then radio, which we can use to transmit messages, including music that we can listen to in the car. And on the other end of the rainbow, next to violet, we have ultraviolet, we have X-rays, which can go right through your body and take pictures of your bones, and we have gamma rays, and if you're in the comic books, that'll turn you into a superhero, or maybe a supervillain. So we're going to look at infrared light. By the way, all these colors you can see are coming from outer space. This is a picture of a galaxy, which is made up of stars, and our star, the sun, is glowing in all of these colors, but they don't all get down to the earth. Even if you could see all of these invisible colors, you wouldn't see them coming from outer space, and that is because our atmosphere, the air, blocks the gamma rays and the X-rays and most of the ultraviolet light, but not all of it. And because these are dangerous, we're lucky they're blocked, we have to wear extra sunscreen protection during the summertime to help protect us from the ultraviolet light of the sun when it's up really high in the sky. Also, the infrared light, a lot of it is blocked by our atmosphere, but some of it gets through, and some of the microwaves and the radios get through as well. And it's not just air that blocks some colors of light and invisible light and lets other ones through. Other things do that as well. So let me get a window, a piece of glass. You want to hold that, Lucy, in front of you? So light goes right through the glass, so you probably haven't thought about how weird it is that you can look through a solid object, basically looking through a wall. The visible light goes right through, but the infrared light doesn't. So if we look with the infrared camera, let's put it right here, notice we can see her hands holding the glass on the side, but we can't see her through the window. The infrared light bounces off of it. In fact, the infrared light bounces off of it just like a mirror. So if we turn it slightly more so it's facing right at the camera, you can actually see my reflection, my infrared light bouncing off of the glass and into the camera, and you can see my reflection, or we can see the reflection of the camera. So there I am, my reflection, my infrared reflection bouncing off of this infrared mirror, this piece of glass. And it works the other way too. We can have things that block visible light. So here's the garbage bag. It doesn't just block visible light or reflect visible light, it absorbs it, which is why it's dark. You know, you can't see Lucy inside there, but with the infrared camera, we can see her.
I can see you.
Oh, you gotta. Yeah, we put a hole in with the light to get through. So we'll block her. She can't see us. We can't see her directly through there, but we can see with her in infrared light. Can you wave to us from inside there, Lucy? And can you give us a big infrared smile? Yeah. So it works both ways. Here we have visible light being blocked by the garbage bag, but the infrared light goes through. That makes infrared light not just interesting, but very useful. In fact, if you remember a few years back, when they were looking for one of the Boston Marathon bombers, they were able to find him hiding under a tarp in the back of somebody's boat with an infrared camera looking down from a helicopter, and they could see him moving around underneath the tarp. It's also used in astronomy because out there in space there's big clouds of dust. You can't see through the dust clouds, but with an infrared telescope you can look right inside the dust clouds, and we can see baby stars forming inside those clouds of dust. In fact, the next big NASA space telescope that's going to go up, kind of the successor to the Hubble Space Telescope, is the James Webb Space Telescope, and it's going to be an infrared telescope. It's going to be looking at the infrared glow from things in outer space. Hope you liked seeing our infrared camera today. If you have any questions about infrared light or any of the other invisible colors, let us know in the comments. If you have any suggestions for what else we should look at with the infrared camera, you can let us know in the comments. As always, thanks to museum members and Visionary Society members for your support, and we'll see you next time.
Bye.
Bye.